It could be a dangerous person. So, there's a sense of urgency and uncertainty. Like you see a visitor in your backyard, and you're worried that the visitor is going to show up at the front door, so you're worried about what to do in the short term. The newly released images from Spain, Thailand, and Norway, 3 completely different countries using 3 independent telescopes on 3 separate nights of observation, all recorded the same seemingly impossible pattern. Comet 3 I-Atlas did not fragment, weaken, or fade as the familiar laws of physics would predict. On the contrary, it was so stable that it stunned the scientific community. Its core is getting more and more compressed, while its corona is expanding faster than any model could have predicted. Most remarkably, the comet's symmetry, which should be the first thing to collapse when a celestial body begins to disintegrate, has not decreased, but has increased markedly. This is a phenomenon that natural objects do not exhibit. In the universe, when a comet enters the fragmentation phase, chaos prevails, structure breaks down, and symmetry disappears. Yet 3I Atlas behaves in the exact opposite direction. This anomaly has led many researchers to start wondering whether we are witnessing a strange form of matter, a previously undocumented gravitational mechanism, or even a completely new law that does not belong to nature as we understand it. Bold hypotheses are emerging, as the data seems to indicate that this is not simply a comet. It could be a sign of another principle of motion, something beyond the current scientific framework. And if all this isn't enough to pique your curiosity, stay tuned, because these images may not only be evidence of a strange phenomenon, but also hint at a new way the universe works, one that doesn't seem to have come about naturally. The first new image, taken on November 22nd in a long exposure from Extremadura, Spain, is immediately striking for the near-perfect cleanliness of its central structure. While the stars in the sky are drawn into long streaks due to movement, 3I Atlas's core remains perfectly still, bright, tight, and centered, as if any wobble could not affect it. It's the kind of stability that even the largest, youngest comets struggle to achieve under real-world viewing conditions. Looking closer at the area around the front axis, a strange detail becomes even more apparent. The light that had been asymmetrical in the previous series of images now appears sharper, as if the energy that fueled the phenomenon continues to intensify rather than naturally diminish. Normally, as dust and ice are ejected from a comet, the asymmetry quickly becomes chaotic and distorted. But here it not only persists, but grows in a more organized way. When a structure is both perfectly stable and exhibits a kind of intentional asymmetry, science is forced to ask whether there is some mechanism at work, some hidden, even controlled dynamic. And if so, 3I Atlas may be more than just a comet passing by. It may be a physical messenger, a signal of something we have yet to name. The next observation data came from Rayong, Thailand, and it brought a completely different surprise. The weather conditions at the time of recording were far from ideal. Thick clouds, a lack of transparency, and a highly scattered background light that would have made most ordinary comets faint, distorted, or even invisible. Yet 3I Atlas remained incredibly bright, as if its luminescence operated independently of any environmental influences. As observers processed and enhanced the data, the central region of 3I Atlas appeared full and bright, almost forming a complete halo. Outside of that, the light spread out in distinct layers, resembling stacked seashells, a halo effect that many experts described as unnatural because of its extreme neatness and order compared to the chaotic nature of comets. In the turbulent atmosphere of Rayong, such sharp layering would be nearly impossible. What surprised astronomers even more was that the brightness gradients obtained from Thailand were almost identical to the data observed in Spain. The 2 observation points were half a world apart, 2 completely opposite atmospheric environments. But the recorded signals were surprisingly similar. This consistency goes beyond the possibility of a random occurrence and has many people wondering, is 3I Atlas operating according to a previously unknown physical mechanism, or is it emitting a kind of signal pattern that is maintained intentionally? This further raises the suspicion that the phenomenon we are witnessing may not be entirely a part of the familiar laws of nature. Now comes the data from Norway, which has been making the rounds on astronomy forums simply because of how unusual it is. The observations were made at Bortal over a short exposure of about an hour, but what was recorded was incredibly detailed. The outflow of material from 3I Atlas shows a soft, faint, but seamless curve, as if the material were twisting slightly as it moved outward. That kind of undulation is usually only seen when a rotating object is stable, suggesting that its structure is not broken but moving according to an organized pattern. What really caught the eye of observers was the striking similarity between the results from 3 different locations: the distinct layering of the halo in the Thai data, the perfectly symmetrical central core recorded from Spain, and the steady rotation signature in the Norwegian observations all pointed to the same pattern of behavior. The core of 3I Atlas seemed unusually stable, its rotation orderly and consistent, while the halo expanded much faster than any scientific prediction. When 3 independent sets of observations, 3 different atmospheric conditions, and 3 recording methods all lead to such a consistent conclusion, the big question begins to arise. Is this really just a comet? Or are we dealing with a mechanism that goes beyond the familiar laws of nature, even resembling a controlled structure? This inexplicable perfection is what the astronomical community cannot ignore. In addition, new data obtained from a wide-field observation in Virginia also contributed to strengthening all of the above comments. Although recorded under large field of view conditions and suboptimal resolution, the information obtained is surprisingly clear. In this data, 3I Atlas's tail appears extremely faint but much longer than previously recorded, like a thin thread of light stretching far into space. Its length is beyond expectations for an object moving at high speeds, and especially it still maintains a regular structure throughout its length, something rare for comets that are susceptible to the impact of the solar wind. What is remarkable is that while peripheral details become blurred as the field of view widens, the central core of the 3I Atlas remains absolutely clear and intact. The bright core is bold, sharp, and shows no signs of distortion or loss of brightness. The combination of an extremely long but stable tail and a core that retains its structure even when observed at long distances and through a wide field of view further accentuates the unusual nature of the 3I Atlas. The Virginia images, though only an additional perspective, inadvertently demonstrate a consistency between previous observations. A comet that appears strangely placid, but behaves in ways beyond current understanding. And it is the absolute stability of its core, despite all the fluctuations in its outer layers, that is pushing the story of 3I Atlas further and further away from the comfort zone of conventional science. The most unusual thing emerged when comparing data from Spain, Thailand, and Norway. The halo and frontal emission region were constantly changing, but the central structure of 3I Atlas was completely unchanged. In all observations, the halo expanded rapidly, the forward light intensified, the tail sharpened, and the core remained perfectly circular. If the object were disintegrating, symmetry would be the first thing to break. Yet here it was getting stronger and stronger. The consistency across multiple countries, multiple telescopes, and multiple times suggests that this is not an error or a coincidence. They all record the same thing. The central core of 3I Atlas is so stable that it defies the laws of nature. NASA is expected to release the next batch of high-resolution images soon. When they do, we'll be looking at the sharpest images yet of 3I Atlas. If these models hold, if the core remains stable while the halo continues to expand, astronomers will be forced to reconsider what this object really is. Because right now the data is pointing to something that doesn't fit the Comet model: stable rotation, symmetrical structure, increasing forward emission, while still actively ejecting material. It's not how natural objects behave when they break down. It's how they behave when they operate. I will continue to monitor any new frames from observers around the world as they come in. Because if 3I Atlas continues to surpass expectations, the next images may show us what we are really seeing. Don't forget to subscribe to the channel, as I will update as soon as the latest data is available.